Hello, my name is Peter, and I'm the founder of Alight, a data-driven smoking cessation aid. And this is my team. Raj?
Hi, I'm a software guy.
Dan?
Project manager.
Zishan.
Mechatronics engineer.
And on Skype we have Luigi.
The hardware engineer.
We're a Canadian startup based in Toronto, already gaining traction here in the field of healthcare research in partnership with the universities and addiction centers. We want to launch the commercial vision of our product in the much larger US market. We believe that the insurance structure in the US healthcare system, which is more competitive and more data-driven, offer us the greatest opportunity to reach enterprise clients. We've come as far as we have because of the strength of our team and the quality of our work. We've connected with people in the industry, we know our product works, and now we just need the resource to put it into the hands of smokers everywhere.
Hello, this is Zishan of the Alight team. I'm going to be walking very quickly through a breadboard implementation of our design. As you can see, it has four main components: the FTDI chip for USB communication, the Atmega 328P, which is the microcontroller, the external EEPROM for data storage, and the GPS unit for satellite data retrieval. The microcontroller is in charge of interfacing all the other components and is also in charge of managing the constraint modes. So far we have three limit modes. We have limiting by frequency of use, limiting by the time, and limiting by geolocation. Currently the geo-locking mode is under development. So far the system works as follows. When the user presses the button, the red LED, which we're using as a replacement for the heating element at the time being, lights up, and then when the user lets go, the GPS system searches for a fix with the satellite. The moment it gets a fix, within the 10-second window we've set for it, it sends the data to the microcontroller. The microcontroller in turn then sends the data to the EEPROM for storage and related retrieval, which I'll get to in a minute. Once the GPS is able to grab a fix, it stops searching for a fix, which is indicated by either a constant fix slider and a constant blank light, and the whole system goes to sleep. On the screen you can see a simple interface I put together for the testing of the design. Once connecting to it over USB, you can select where to save the file and just get the GPS data. This creates a CSV file on the desktop, which we will open, and you can see it contains all of the data. These three are the time, this is the date, and this is the longitude and latitude. For the final product, we hope to put together a more polished and intuitive interface. What you see in front of you is a mock-up for the website, which is still in development. The design includes various data interpretive devices, and the user is also able to set their preferences and various constraint modes, which I will demonstrate next. This is a brief demo of the constraint mode. I'm going to be demonstrating the frequency limit mode, which limits by the frequency of use. So we put in, the user enters 3 and then sends the data. Then moving back to the breadboard, we can trigger the system 3 times. So 1, 2, 3. And then on the 4th try it shouldn't light, as you can see. The delay is because it's checking whether or not the constraints are being met or not. And as you can see right now, the GPS is trying to get a fix and will send the current location, time, and date of when the user triggered the system to the microcontroller, which will store it in the EEPROM.